Hello everybody. Today we're going to look at how to make Excel plots. So Excel is a cheap and cheerful way of quickly making plots. As Jake will tell you, they don't look the prettiest, but because Excel is pretty much on every computer that you will find, or some version of Excel, it's very good for just quickly visualizing either a function that you haven't seen before or your data and see, what kind of shape your data is taking. So today we're going to be looking at the free induction decay function, which is the shape of NMR signals. You'll remember this example from tutorial a couple of weeks ago. The function here is f of t is a e to the minus I omega t minus kt. Now k is 1 over tau, so if you substitute this part in, it'll be exactly the same as the example you were given in tutorial. Now the tutorial question asks you to separate this into the real and imaginary parts, find the oscillating and the exponentially decaying terms, and then plot it to see what it looks like. So we'll skip right to the dessert, as it were. I've done this part, the real part, for you. So the real part of f of t is a times e to the negative kt of cos omega t. And the question we want to answer right now is, what does the real part of the free induction decay curve look like? So we'll go to Excel, and I've already set something up to make things quick and easy, hopefully. So the rate constant here, I've made 2, and I've called the rate constant k. So in every version of Excel, you can name your cells, and that will make things easy for when you want to use them as constants. Angular frequency, I've called O for omega, and the pre-exponential term is A for, well, that's the pre-exponential term. And I've just given random values to these. On the column A here, I've set up the time values. So I've started with time at 0, time at 0.1. So this will tell Excel how much to increment the time steps by when I eventually drag it down. On the right, you see I've got a column called signal intensity with arbitrary units. And if you look at the expression for the cell, it's a formula, and the formula is just the formula I read out a couple of minutes ago, a e to the minus k t times cos of omega t. And all I've done is I've dragged it down one column. I'll show you how to do that. So you just bring it down here, drag it down, and it automatically fills the second column, this bottom row, with A3, because A3 is our new time value. Now what I'm going to do is I'm going to take this and drag. Okay, I'll show you one at a time. So I'm going to select the time column, both of them, because that tells Excel how much to step time value by. I'm just going to drag it down to 4 seconds. And I'm going to do the same. So I'm going to take signal intensity, I'm going to drag it down so that it gets to 4 seconds. Now you'll see here that it's automatically filled out the signal intensity at each point in time. The point in time being the point in time on the left-hand cell. Now if I select both columns, drag it down so that I've got all the data in here, I can go to the charts part and insert a smooth marked scatter plot. And you'll see that the scatter plot is just our free induction decay curve. So it's got the signal in the y-axis and time on the x-axis, and it's decaying away exponentially, but it's also oscillating. So it comes down and then goes back up, and you can't see it that clearly here, but it's also coming back down after about 3 seconds. So now we're going to just play around with this because I can. I'm going to change the angular frequency so it's higher. And you see it's made a huge change in our FID curve. Now the oscillations in the free induction decay become much more apparent, and you can see them much more clearly. Anyway, so if you set this up yourself, you can play around with it a little bit more, see how changing these values changes each of the terms. Yeah, so happy hunting. You should do this for the imaginary part. So solve for the imaginary part and then plot it up in Excel. When you do that, what you'll want to do is just call this column I times the signal intensity, and then instead of writing I times in here, you leave the I out, and just remembering that what you're seeing is the imaginary part of the signal. Okay, I think that covers pretty much everything you need to know about making a plot in Excel. As you can see, it's very quick, very easy, and you can see what the signal looks like immediately. Let's go to a prettier value. So make this small. That will look nice. Okay, well, that's all I have to say on this subject.